other rare disease that we're working on is called sorbitol dehydrogenase deficiency, or SORD deficiency. Sorbitol dehydrogenase is the enzyme that typically follows aldose reductase in glucose metabolism. So in galactosemia, we were talking about galactose as a sugar, and that aldose reductase converts galactose to a sugar alcohol called galactitol. But aldose reductase as an enzyme can also work on the sugar glucose, and it converts glucose to a sugar alcohol called sorbitol. And there's another enzyme called sorbitol dehydrogenase that then picks up that sorbitol and converts it to fructose for energy production. Patients with sorbitol dehydrogenase deficiency, or SORD deficiency, are missing that enzyme. They have a mutation that causes that enzyme to either not function properly, or for the enzyme to not be produced. And as a result, aldose reductase converts glucose to sorbitol, and then sorbitol has nowhere to go. There's no enzyme existing there to convert sorbitol to fructose for energy production. And as a result, these patients develop very high levels of sorbitol in their blood and tissues. And just like galactitol is toxic to certain neurons in galactosemia, sorbitol is also toxic to neurons and has a profound effect, especially on motor neurons. So patients with SORD deficiency develop an axonal neuropathy, or motor neuron disease, where they lose the ability to walk and run, their mobility and motility over time. It's primarily a lower limb disease, so you see most of the effects on the legs, on the lower limb mobility, but some patients also develop a progressive worsening of symptoms in their upper limbs as well. So it's a motor neuron disease. There's no treatments approved for SORD deficiency as well. That's what we do. We develop drugs for diseases with no treatment options. And there's a very clear role of aldose reductase there. So these patients are missing the enzyme responsible for sorbitol metabolism. But what if we can stop sorbitol from even being produced by blocking aldose reductase and stopping conversion of glucose to sorbitol? So that's the approach that we've taken with that disease. We have very clear biomarker data from our phase 3 showing that treatment with Govorestat, or AT007, really substantially reduces sorbitol levels by about 50%. It was highly statistically significant versus placebo. And many of the patients that we treat, we actually bring their sorbitol levels down to the normal range of patients. So that has a potential effect to really halt disease progression there. The phase 3 study that we're doing in patients with SORD deficiency is looking at lower limb function over time. So we do a test called the 10-meter walk-run test, which is how long does it take you to go 10 meters, whether you're walking or running. So some patients who are younger and earlier in the disease process, they can still run. A lot of the patients, as they get a little bit older, obviously their lower limb capabilities are limited and they can barely walk. But it looks at the progression of your lower limb symptoms over time. So we've shown in this disease population that your sorbitol level is highly correlated with your ability to walk and run. And we've already shown that we can greatly reduce sorbitol levels with Govorestat treatment. So the next step is showing that we can actually impact their lower limb capabilities, their 10-meter walk-run speed, with the drug treatment. And that's the phase 3 that's ongoing right now.